Our solar system story begins long before our sun first ignited. Picture a vast cloud of gas and dust, remnants of an ancient supernova explosion. This wasn't just any cloud, it was a stellar nursery, a place where stars are born. This cloud, called a nebula, drifted through the cosmos, filled with the building blocks of planets and stars. Within this nebula, gravity was already at work, pulling particles together. The nebula began to shrink and spin like a graceful waltz. This spinning motion would dictate the motion of planets for billions of years. Imagine the nebula now, a swirling vortex of gas and dust. As gravity pulled more material inward, the center of this cloud became increasingly dense and hot. This central region, destined to become our sun, was like a cosmic furnace, its temperature steadily rising. The cloud wasn't uniform, it had areas of greater and lesser density. This uneven distribution of matter played a crucial role in the formation of planets. The spinning cloud began to flatten into a disk, a shape reminiscent of a cosmic frisbee. This structure, known as a protoplanetary disk, would become the birthplace of our solar system's planets. Within this disk, the seeds of planets were being sown. The heart of the collapsing nebula, the protostar, continued to heat up under the immense pressure of gravity. Temperatures and pressures reached a critical point, a point where atoms could no longer exist independently. Hydrogen atoms, the simplest and most abundant element in the universe, were forced to fuse together. This wasn't just a chemical reaction, it was nuclear fusion, the very process that powers the stars. The fusion of hydrogen into helium released unimaginable amounts of energy, flooding the surrounding disk with light and heat. Our sun was born, a brilliant star that would bathe the solar system in its life-giving energy for billions of years. This event, the ignition of nuclear fusion, marked a pivotal moment in the solar system's evolution. Section 4. From dust to planets, the accretion process. Within the swirling disk surrounding the newborn sun, a cosmic ballet was underway. Dust grains, remnants of the original nebula, collided and stuck together. These tiny particles, drawn together by electrostatic forces, formed larger clumps. Over time, these clumps grew into larger and larger objects, a process known as accretion. Imagine these early solar system seeds called planetesimals, ranging in size from meters to kilometers across. The protoplanetary disk was a chaotic place, with planetesimals constantly colliding, some merging together, others being shattered into smaller pieces. Gravity played a key role, pulling in nearby material and causing the planetesimals to grow larger and larger. These planetesimals were the building blocks of planets, slowly accumulating mass through countless collisions. Section 5. Planets of rock and gas. A tale of two disks. The protoplanetary disk wasn't uniform in temperature. Close to the sun, where temperatures were scorching, only rocky materials could withstand the heat. These rocky materials, like silicates and metals, became the building blocks of the inner planets, Mercury, Venus, Earth and Mars. Further out, beyond what's known as the frost line, temperatures were much colder. Here, ices made of water, methane and ammonia could exist in solid form. These ices, along with rock and metal, provided the material for the gas giants, Jupiter, Saturn, Uranus and Neptune. The gas giants, with their immense gravity, were able to attract and hold on to vast amounts of hydrogen and helium gas, becoming the behemoths we see today. Section 6. Our cosmic neighborhood, a solar system in perpetual motion. Today our solar system is a place of both order and dynamism. The planets, guided by the sun's gravity, orbit predictably. Yet the solar system is far from static. Comets, remnants of the early solar system, streak through space. Asteroids, rocky bodies pose a small threat to the inner planets. From Enceladus's geysers to Io's volcanic plains, our solar system is full of wonder.